folks, welcome back to Walter's Aircraft Works. That is a water inlet for our Cummins 4BT. As you can probably tell from that logo, we manufactured that part as well as these reducers for our intercooler using the aluminum sand casting method. It was a long process, took us quite a while to spool up and tool up to manufacture these parts. Made a few mistakes along the way, but certainly learned a lot as well. We'll take you along with us on that journey if you're willing to watch, and hopefully you can learn something too. We started off by making this siphon burner. The siphon itself was bought through eBay for about $20, as well as the 2-inch by 12-inch stainless pipe. The bits and pieces were then put together, assembled, silver soldered, and we use about 15 psi regulated pressure to pull in diesel fuel or kerosene, and it's blown into a furnace here that was made from an old hot water heater tank lined with Purolite, S-concrete, and fire clay. As we were assembling it, we noticed it started to look like R2D2, so we named it R2 Heat 2. Once we made the burner and the furnace, we needed to make the crucible and the tools required to handle the crucible. The crucible is made from a piece of 8-inch pipe that I picked up from my metal supplier. We welded a 3/8-inch plate in the bottom of it and some lugs on the side of it. Once we got the crucible made and the tooling, we decided we needed to melt down and purify our aluminum that we'd been saving over the years. It was greasy and dirty, and heating it up to a molten state and then scraping off the dross off the top purifies it. And we poured it into our ingot trays, and I think we wound up with about 42 pounds of usable aluminum ingots by the time we finish this purification process. Alright guys, this is the first piece that we're going to try to sand cast. This is the return from the radiator back into the engine for the coolant, and as you can see, this one kind of angles down. We would like it to go straight out to make this transition up to this pipe easier. This one's actually not the right angle either. I kind of screwed up when I ordered this radiator and didn't realize that this pipe kind of angled off. Hard to tell from that angle, but there you see it kind of angles off to the side there. And I'm not sure whether I'm going to just deal with that issue or try to cut that pipe and re-weld it back onto the radiator to angle it or to get it to come straight out, or even actually if this was kind of canted down about, you know, if we turn it about 90 degrees, it'd probably help us out, but we'll deal with that a little bit later on down the road. But this is our piece that we're going to cast, and I'll show you how I'm going to do it. Well, it just so happened that I had another one of these housings, and this one was even a different configuration. The neck on it turned down even farther, so not going to work for our purposes or what we need to do. So originally I was thinking that I would just weld this together. This is a cast aluminum, and I was just thinking about, you know, I cut this piece off. I was going to heliarc this fitting onto here and then be done with it. And it's still probably the quickest way to get it done, but I've been trying to, you know, figure out a way to get into this casting stuff. Just opens up so many doors when you can cast your own parts. So I figured this would be a good piece to start on, and if we fail at it, we can always come back to this. But right now, today, I'm going to use this for making a template for our pattern. So I'm going to start with a piece of cardstock here. All right, let's see. Pop that off. I'm probably not going to put this recess in here. I'll make it flat across here. It'll be easier to cast that way, so at least I hope it will be. All right, that ought to be a pretty decent template to get started on our pattern. All right, I glued up some poplar here, some just leftover scrap, and I've cut actually another template and left the center in it so I could find the center of the hole. What I want to do is I want to line the center of that hole up with our parting line here. Now when I glued this poplar up, well, let me back up a little bit here. This is not the first time I've attempted this pattern. This is the first attempt. Everything was cooking along real well until I had to cut it. You know, I don't know what I'm doing here. I'm figuring this out as I go. So I figured I'd cut it in the center and add a piece of wood in here to make up for the curve. Well, that was more difficult than I thought, and I didn't get it cut down the center. Couldn't hold it in the saw. You know, it's an awkward shape, all that. So hence moving on to round 2 here, or the second prototype. And this is why I've laid up this poplar a little bit different. Do you see this one? I laid up the glue joints going this direction. This one I've turned it, or this blank I've turned it to go this direction. When I glued them up, this center glue joint here, I put a piece of just regular paper in there. You know, tip from old Mr. Pete 222 tubal cane. If you glue it up and you want to split the seam again, if you put a piece of paper in there, it'll split a lot easier. So I'll just wood glue, piece of paper with a little real light glue on both sides of it, and then laminate it together, let it dry. So now I want my center line for this hole to be right where that seam is going to be. Let me double check, make sure I got the pattern right here. I do. This is going to be the bottom of the casting, and put my little brad through, line it up with the center of that seam. Well, I need a thumbtack or a safety pin or something, but so something similar to that. And then I will mark around it, and then we'll go over to the table saw and the chop saw, maybe bandsaw, I'm not sure. I'll have to whittle it out. I do have a wood bandsaw, so I can whittle it out with the wood bandsaw. But a little different here on draft. And the draft is the angle that they put into a part to make it come out of the mold. And I think it's about 1.5 degrees, maybe a little bit more than that, is what the draft should be. And obviously this one was drafted for the mold to come apart this way. Well, like I said earlier, at least I think I did, this was at least a 3-piece mold, because you can see this parting line kind of darting off that way. And if you look at the way this casting, it would have been easier if I wouldn't have cut it all to pieces, but anyways, it's not symmetrical, so it can't be done with a 2-part cast. It has to be a 3-part casting at least. Way beyond my abilities at this point. Or maybe they just had, I don't know how they did it, to be honest with you. They had more capability than I have at this point. So, draft. Well, I'll probably widen this out a little bit and create a draft going this direction, and then this has already got kind of a natural draft to it here. So that's the plan of attack that I'll use. Is I'll widen it here a little bit, and then taper it down to this end, and then this will be a natural draft here. That should get the job done. That's kind of interesting just looking at it. Here's the parting line. So that's got a taper to it, a natural taper to it, and so would that. So yeah, we're just adding a wee bit right there and a wee bit right there. So I think that'll work. I'll rough it out. I'll probably leave it a little bit plush to the line. There is a calculation to use for shrinkage. Aluminum shrinks, what is it, about 1.5%, something like that, but not a big factor here. All right, I glued up some more poplar with a piece of paper in the middle to make our spout here, as well as our round pieces that holds our core, makes the impressions to hold our core. And I left it square for a reason. I'm going to put this in my metal lathe in the 4-jaw chuck, and the corners are going to help me center it in the 4-jaw. The other end of it I marked with an X just to put my live center in. This is not a great use of a metal lathe, but I don't have a woodworking lathe, so it'll get the job done. All right, well, back from the lathe, and made some square pieces round, or rectangle pieces round, and get pretty good, I think, about keeping the parting line right dead center on these pieces. Took a little bit of finagling with the 4-jaw to get it centered upright, but I think I did pretty good. So also, I'm back from the sander with this, or the chop saw. I hacked most of it out with the chop saw, and then laid it up against the sander, and just tried to imagine that parting line being right there and keeping that on a taper from the parting line this way, and then the same from the parting line back here, so we have our draft. Height is right. 2.5 inches is how thick this one is. It's going to leave us plenty of material. This hole is bigger than our hole is going to be, so we're going to even have more wall thickness in here, and that'll be good. All right, so this is the right side there. Let's see, template here, template fits here. This thing's not symmetrical, so you gotta make sure you don't have the thing upside down. So this piece will go right here for the core, for our sand core. So I'll need to drill right on the center line there, 1.5 inch hole for our core. And this then we'll need to have, I can't remember what size this is, but I'll have to bore a hole for this to be glued into there. And then after that, it'll be Bondo to put some fillets. I'll probably, this edge I'm going to leave sharp, I think, because it's going to get milled anyways. I might knock the edge of it off so it'll come out of the cast better. That's probably the smart thing to do. And then I'll be able to mill. I got plenty enough thickness here to mill off whatever I need to. I should keep this stuff in frame, huh? I got plenty enough thickness on this flange to mill off more. So if I add a little bit of a radius, so the pattern comes out of the mold a little better, out of the sand better, that'll be fine to mill off. And then of course on this other side, which would be this side, I can I haven't put quite a radius on that. So I think I'll do that first. I'll sand these up, and then I'll get to boring these for that piece to fit, this piece to fit, and then it'll be just a little bit of Bondo work, and then we'll have to cross our fingers for splitting it. All right, one down, one to go. All right, there's the second hole drilled up, and it fits good. I'm gonna probably epoxy them in and then let them sit overnight, and then I'll see about splitting. I'm also gonna have to kind of back up and punt a little bit. I didn't drill any dowel pin holes in this thing to help me line it back up once we do have it split apart. So I think I'll have to try to put one, maybe one in here. You know, I don't know, maybe another one over here. Should have done it. I guess you only, well, could, well, I don't know how they do that, but we'll figure out a way to do it and get it done. All right, our pattern is cured up here as we epoxied the plugs in here, and I might have screwed up again. This thing was already showing signs of wanting to separate here on this seam that we put the paper in, and when I epoxied it together, I clamped it, well, actually a couple of different directions, and I hope this epoxy is not going to make it difficult to split, but it certainly has stiffened it up. But before we split it, we need to put a couple of dowel pins in here. I should have done it before, you know, I originally glued up these laminates here. I should have put some pins in here, so to help reconnect the pattern as we put it back together, you know, to make the impressions in the sand. So I'm going to do that now. The surface finish on this piece won't make any difference, and it won't on this piece because they're just there to make the impression to hold our core. So I'm going to drill a 1/4 inch hole here and a 1/4 inch hole here. I'll do it over on the mill and try to make it as centered as possible. And I've got just some cheap aluminum rod here. I think I'm going to epoxy in the hole once I get this thing split apart. But let me drill the holes first, and then we're going to try to split this thing. All right, a couple holes in here, and I'll make a couple of pins to go in those holes. But let's see if we can get this thing split. Right about now, I'm wishing I'd have taken a different route with that epoxy, because I think this would have split right open. All right, well, not a perfectly clean break, but I bet I can fix that and clean things up. And we're gonna get the Bondo out here in a minute anyway. So whether I chisel that off of there and glue it back in, or just Bondo that flat, either way it's gonna work, I believe. What's the takeaway from this? I think I really screwed up when I got the epoxy involved here to glue these pieces in. There's certainly a better way of doing that. Well, you can see that epoxy ran all into this, into the end grain here. I think it with just the paper in there and the regular white glue, it would have split right apart. It would have been easy, but of course I screwed it up. All right, let me try to chisel this off and see if we can glue it back in. All right, let's talk a little bit about cores. I'm trying to figure out how to make a core box here. That's the device that's gonna make our sand core, which is gonna create our void inside of our casting. And hey, sorry if this video is going to be screwed up. There's a lot of backing up and screwing up and then refilming this stuff, and I know when I go to edit it, it's just going to be a bunch of hodgepodge put together. But oops, hey, look at that, penny for your thoughts there. Well, the way the market's going, I'm going to need that for retirement, so put that off to the side. All right, so cores, concentrate, Don, concentrate. All right, so this is what I'm planning on doing. I'm planning on putting this together sort of like this. You can see I've already started cutting this. I'm going to try to glue it together with the PVC glue now, and hopefully that'll stay together when I split it. When I split the elbow, finish splitting the elbow, I've left a couple of places here on the elbow to finish it up, and then once it all gets glued together, hopefully it'll split apart. We can clean it up, put it back together with some tape, or hose clamps would be nice to put a couple of hose clamps around it. We'll pack it full of sand, we'll harden that sand, and then we'll be able to split those two halves apart again and be able to use it for our core. If we look at the pattern that we're making now, that sand core ought to fit right in our impression that we make in the sand. And these two sections here ought to hold it in place to create the void for our casting. So that's what I'm doing. I'm gluing this together. Probably not the prettiest, but I think it's going to do the job. I hope it is. The center, most of this cutting I've done, this I did all with a razor blade, just by dragging my utility knife back and forth across here enough times to get it to split. I didn't want to really cut this with the table saw or anything that's going to create a wide curve in it, because I want to keep this dimension, this inner dimension, as close as I can. Now I started the elbow doing the same way with the utility knife, and I dragged and I dragged and I dragged, and man, I was just getting nowhere. So eventually I did wind up taking it over and putting it on the bandsaw, on the wood bandsaw. It's got a real thin curve on it, and I cut it, and right here there's a little section that hasn't been cut yet, and the same right here. So I think I can finish it up quick enough once it's glued together. I think it'll split right apart. So let me get the glue in here and we'll see how this turns out. You know, in hindsight here, I probably could have just glued it together first and then just run it through the bandsaw. Would have probably been just fine. But we'll see. If this fails, then that's the direction I'll go. Let me see. Oh, isn't it the case? Every time you go to use your PVC glue and cleaner, it's dried up. You crush the cans trying to get the lids off. Alright, well, I think this stuff's going to be alright. I got a lot of dust going on in here. Shop's a mess again, as usual. Oh, this cleaner's old. Been around the block a few times. Ooh, not much purple left to it. It's all yellow. I wonder what that's all about. Really old. Okay, plumbers, don't get mad at me. Alright, this is just regular old clear PVC glue here. Nothing special about it. Stuff I've had in the cabinet for quite some time, but let's see how well it works. Gotta line these seams up. Alright, well, not a perfect joint there, but probably ought to have a C-clamp right there. Let me grab a clamp. Well, I think I said C-clamp, but you know what I mean. Hose clamp. Got a couple of them on there. Maybe that'll squeeze it together good. Alright, nice liberal slopping of the goo. And let's see if we can hold these together. Uh-oh. No. Okay. Alright, those seams line up a little better. Oh gosh, keep it in frame, dummy. Keep it in frame. Huh. Not sure why that's not lined up there. A little cattywampus, but oh well. Well, probably get the job done. So we'll let that set up a few minutes and see if we can get that split apart, see if we got something that's usable. All right, let's see if we can split it open here and see if we have something usable. Oh boy, it's been dangerous. Alright, get these clamps off. Huh. Alright, not so bad, not so bad. This, I'm not sure if I'm going to lay a little Bondo in here and try to smooth these edges out a little bit. You know, I looked at making this out of a sewage or a drain elbow, because I think they try to mold them where they're faired out a little better in here. But the problem is the 90 was just too sweeping. It was too big. It wasn't going to be able to make the turn in here the way we need it to make the turn. It needs to be a tighter radius. So that leaves me with either fairing it out, or once we split it, once we pack it full of sand and harden the sand and split it open, might be able to pull the core out and then clean the core up. I've seen people kind of scrape the edges of the core where there's a parting line and clean that up, but I've never really seen anybody try to shape the core much after they pull it out of the core box. But I may try to clean it up a little bit, just lay some Bondo in there, sand to scuff it a little bit to give the Bondo something to catch to, or a little tooth to it, and then try to fair it out a little bit and clean it up. I don't think it's going to make a big difference in our actual casting. Theirs feels pretty smooth in here. A little catch right there on looks like maybe some casting material that squeezed through on a mold line or parting line. They certainly have a lot more material, or a lot more area in here that they had to account for these plugs or pipe threads to put in different openings or temperature probes, I think is what this was all about. Or actually, I think the return for the heater core comes in one of these, and then the other one was a temperature probe, and the other one was return for the heater core. All right, pattern done, except for I'll probably shoot a little bit of gloss on it just to make it come out of or slide out of the sand a little easier. A couple of coats of Rust-Oleum filler primer, and Scotch-Briting between coats, and a couple of pins in there hold the pattern together. And I did add some fillet around here and around here to help it come out of the sand better as well. So I'll shoot some color code on it, and I got another pattern in the lathe now for a reducer for the intercooler, and that's going a lot easier. But hats off to pattern makers. It's tough work and harder than I thought it was going to be. But sandcasting next. Here's another pattern we're working on for the truck. This is a reducer for the intercooler. Necks it down from 2 3/4 down to 1 3/4 inches. I used an intercooler for an F250, an early 7.3. I believe it's got aluminum inlet and outlet. The end caps are aluminum, not like the later generation ones, which I think are basically the same dimension. They just put plastic end caps on them. This is an earlier style with aluminum end caps. It's readily available, and it fit well with the setup that we needed. But I wanted to reduce the inlet and the outlet down on it, and I'm going to try to cast these. So I've turned these pieces on the lathe just like I did before. I laid up some wood, same wood, this is poplar, and laid it up with a piece of paper in the middle, and I'll try to split it here. Remember, the last one didn't split so well because of epoxy problem, but hopefully this one will do better. Oops, sorry about that. Well, that's already harder than I wanted it to be, but I almost want to stick it back on the lathe and use the live end, whatever that thing is, to split it. But didn't need to. That worked out real well. So thanks to Tubalcane, the paper does work well. All right, so this one's done. I'll still have to drill it and put a couple of pins in it. Again, I failed to do that prior to laminating them together. I'm not sure if that's the smartest way of doing it or doing it now. Doesn't really matter. I don't have the choice to wait till later, but I think I'll just set it over there on the mill and drill a 1/4 inch hole down this. Again, this is set up for a core, and this won't be in the finish of the aluminum, so I can drill through here straight down and then match the pieces up again, and then match drill them. Should be good. And I still have to create a core box, and I plan on doing that with this piece of wood. And I'll trim this edge out. This is the drawing I did to create this. This is what I took the dimensions off from when I was turning it on the lathe. So this outer dimension here is the current shape of this current dimension of this. So I'll trim that off, and then I'll turn this block of wood down to the core size. And then once I get that plug made, I'm thinking I'm going to use fiberglass to cover it, let that cure up, peel it off, do that in 2 clamshells, 2 half shells, and then that'll be my core box. So here we go. All right, here's the core. I turned it on the lathe and shot a couple of coats of primer on it, and then actually put a couple or some packing tape on it to keep it from sticking, and to make the core box. And the core box is a little bit hokey. It was a little bit more challenging to make, but I basically just divided the core pattern here in half, and then laid up. I was going to use fiberglass, but decided to use Bondo, and just did half of it with Bondo, and then a piece of fiberglass cloth to give it a little bit of structure, and then more Bondo, and then some sticks to give it stiffness. And well, I'll show you. It's not real pretty. I don't want you judging me, but I think it's gonna work. So here it is. Use what you got on hand, right? So some PVC, some 4-inch PVC, and it comes apart. Oh, like this. And let's see, this sleeve slides off from it. I know it's ugly, but I think the inside looks pretty good. So again, another couple of layers of just whatever paint you have. And now I'm putting a couple of coats of it's just paste wax on it to keep the core, or make the core slide out of there a little easier. So this is actually, I've put a couple of coats on it already, and I'll polish it off. And the same with this core box as well. I bonded it out, ferreted it out in here with some Bondo and painted it, and I'm putting a couple of coats of wax on it as well. And as soon as we get these waxed up and put back together, we're going to mix up some sand with some sodium silicate in it. I have it, and we'll mix it up and get these cores made. What I don't have right now is 100% CO2. I'm going to use, I think what I'm going to use is my argon CO2 mix, which is probably not a smart way of going, just because it's more expensive, but I don't have any CO2 right now, so I'm going to give the argon CO2 mix my MIG for my MIG welder, shoot some of that in there and see if I can make that work. But let me get these waxed up, and we're going to mix up some sodium silicate and make some cores. All right, here's our sand. It's just silica sand, actually play sand from Home Despot. And it's supposed to be dry, but mine's not quite dry. I've actually got some out in the sun right now, drying out for another project, but I did run it through the sifter here, so it's fairly fine. And now I'm gonna mix it with the sodium silicate. Now I bought this sodium from, I ordered it from Amazon, and I delivered it right to the house, of course. But poked around a little bit, and this is supposed to be 100% sodium silicate, and I think it was about 27 bucks for this gallon, which is probably enough to last me a couple of lifetimes, I hope. But we're gonna give it a whirl. Cement floor sealer, huh? Hey, the people, by the way, the people on Amazon that reviewed this, that used it on their floor as sealer, weren't that impressed with it. But there were people that were using it for the same thing that I'm using it for, and they were impressed with it. So if it worked for them, hopefully it'll work for us, huh? So how much sand did I put in here? Well, enough to fill up our core boxes, both core boxes, and just a wee bit more. So now how do we know how much sodium silicate to put in our sand mixture? Well, a little poking around on the interweb gave me that. It was 5% by volume is what I gathered from a couple of different people. So if more than one person says it, it has to be true, right? Especially if it came from the internet. More than one person on the internet said it. Oops, I'm getting messed up here. Let me pour this back in. I need to weigh the sand, so I have to put it, I got it on the scale here. The scale is on. I'm gonna zero it with the weight of the pan, the tare weight. Perfect. Now I'm gonna add the sand to it. And let's see what it weighs. 38 ounces. 10% of that weight would be 3.8, let's say 4 ounces. So let's say 2 ounces of sodium silicate. So let's add it in there and see what happens, huh? Stuff's pretty thick. There's 1. There's 2 ounces. Not a whole lot. All right, now I'm going to use my my drill and look at that. I'm going to whip it up with that. I'll be right back with you. Okay, I gave it a good thrashing quite a bit before I started letting you in on the game, but it should be mixed up good. Let me kind of scrape the bottom here. Make sure there's no dry corners. Oh boy. Yeah, it looks like there's some wet right down here in the corner. There's some really wet areas, so I'm going to get that pulled up and mix it some more. Alright, I packed this core box with our mixed up sand, and I used a dowel in the center of it to create a hole all the way through it, so the CO2 can get in there in the center of it as well. So that one's kind of big and clunky, and it was hard to film, or hard for me to get the camera in the right angle. So but you can use your imagination, not rocket surgery here. So I'll show you how on this one, I guess, and like I know what I'm doing here. Oh, making a mess, but it seems like you have to kind of pack this sand as you go, so I will do just that. Put a little in, pack it, I'm making a gigantic mess, I can tell you that, and I'm a little nervous about running out of sand here. Hopefully I calculated properly. Probably enough on the bench top here to finish up. But not sure how to put a hole in this one. I saw my Ford boy. He's a great guy to watch. If I haven't mentioned that already, I believe I have. But he's a great guy for this casting stuff. Him and Tubal Kane. My Ford boy, I think that's about all his YouTube channel is casting. And he does some great work. Very educational. But he's the one that I picked up on using that piece of paper for kind of polishing those ends off. Seemed to work well on the last one. All right, I don't know. I'm gonna try to poke my long Phillips screwdriver in here to create a hole in the center. Now let's see, I don't want to really bump into that elbow down there, so I'm gonna only plunge it in about that far. Let's see if this works. Try to go right in the center, right to there. Oh, see if I can polish that out a little bit. Uh-oh, lost my hole. Find it again. All right. This side only go in about to there. All right, well, hopefully that'll work. What I'm gonna do is, if you watch these guys that do it more than I do, they have a CO2 bottle with a hose and some kind of cup or something that they force feed that into into the end here. I'm gonna try to bag these and push all the ambient air out of it that I can, and then just fill it with, like I said, I'm using I think I've said it, I'm using argon CO2 mix because that's what I have on hand, and I'm just gonna pump that in with my MIG gun, and we'll get right back to you and we'll see what it looks like. All right, well, I put them both in the same plastic bag, and then I used, like I said, I used my MIG gun to, I actually kind of blew it down inside those holes on both of them for probably about 15 seconds each, and then I filled the bag up with argon CO2 mix, and I think I'm going to let it sit overnight and just kind of absorb that CO2, and we'll check it in the morning, and of course with you, that'll be just in a half a second. Okay, just that quick, it's overnight, and we're getting ready to open these up. Let's see how we did. Ben's over here opening up the one in the PVC, a core block, and I think what we'll do is slide this off, and maybe a few taps here. And a little oops right there, stuck to the core block. Maybe we can patch that in. Let's see, that'll be certainly usable if we can get it out of the other side. Oh, that feels good. Oh yeah, that's definitely usable. I'll get Ben in here opening up the other one. Very nice, very nice. All right, that's definitely usable core as well. Kind of interesting. It's like maybe didn't get quite compressed right there enough, but certainly both of these are usable cores. So got to make one more of these, and then we should be able to get to work. And while I'm making the second one, I may try to just patch a little bit of sand in there and fill that gap in.